Welcome back, students. Dear students, myself Dinesh, working as assistant professor, Government First Grade College. Dear students, in this session, I am going to explain the concept of isothermal process and adiabatic process, and also PV diagram or indicator diagram. Dear students, let us see the isothermal process. Isothermal process means here during the isothermal process, the changes in pressure and volume takes place at constant temperature, since temperature remains constant. The internal energy of the system also remains constant. I repeat, during isothermal process, the changes in pressure and volume takes place at constant temperature, since the temperature remains constant. The internal energy of the system remains constant. The change in internal energy during isothermal process, that is equal to 0. That is du equals 0 or u2 minus u1. Change in internal energy of the system is equal to 0. Apply first law of thermodynamics. We get the internal energy dq equals some amount of work done, dw. If you take an ideal gas or perfect gas in a cylinder which is fitted with frictionless piston, the side walls and bottom of the cylinder should be perfectly conducting. In this case, during isothermal expansion, heat supplied to the system dq, heat supplied to the system, equals the external work done by the gas. If you move the piston towards, that means inside, if you push the piston, then it undergoes compression. During isothermal compression, the amount of work done on the system equals the heat released to the surroundings. Since the temperature remains constant, hence it obeys Boyle's law. That means PV equals constant. Isothermal process is slow process. Isothermal process is slow process. See in this graph, from A to B, from the point A to B, the temperature remains constant. The temperature remains constant because the side walls of the cylinder should be perfectly conducting, not insulating, conducting. Hence, the curve AB is called the isothermal curve or isothermal. Simply it is said to be isothermal. In going from B to A backside, the system gives out extra heat to the surroundings because the side walls of the cylinder should be perfectly conducting. Hence, the system gives out extra heat generated within the system to the surroundings and maintains the temperature constant within the cylinder. The equation for isothermal process is PV equals RT, that should be constant. This is for 1 gram molecule of a gas is taken inside the cylinder. Let us see the adiabatic process. Here in this process, pressure, volume and temperature change such that heat is neither allowed to leave the system nor allowed to enter the system. I repeat, in this process, pressure, volume and temperature change such that heat is neither allowed to leave the system nor allowed to enter the system. The process takes place in thermal isolation, then internal energy is always equal to 0. Because if you take a perfect gas or ideal gas inside the cylinder, which is fitted with frictionless piston, the side walls of the cylinder should be perfectly insulating. In this case, in the thermal isolation, the internal energy of the system remains, that is equal to 0. If you apply first law of thermodynamics, we get du plus dw equals 0 or du equals minus dw. During adiabatic expansion of gas, work is done by the gas and its internal energy decreases by an equal amount. Hence, its temperature decreases. This is during expansion time. That means when the piston move away from the system, pushed away from the system. That means during adiabatic expansion of a gas, work is done by the gas and its internal energy decreases by an equal amount. Hence the temperature decreases. Suppose adiabatic compression takes place. Then work is done on the gas, not by the gas. Work is done on the gas and its internal energy decreases by an equal amount. Hence, its temperature increases. Then work done is said to be negative. Here during adiabatic compression, work is done on the gas and its internal energy increases by an equal amount. Hence, its temperature increases. Then work done is said to be negative. Because the side walls of the cylinder should be perfectly insulating. Hence, heat neither enters nor leaves the system. During adiabatic compression, temperature of the gas increases. The variation of pressure and volume of a gas satisfies the relation PV raised to gamma equals constant. Here gamma is the specific heat ratio, that is Cp by Cv. This also satisfies the relation T into V to the power gamma minus 1 is also equal to constant. The process that takes place suddenly or quickly are adiabatic process. Totally adiabatic process is sudden process, isothermal process is slow process. See PV diagram or indicator diagram. PV diagram, that means pressure volume diagram, is a graph which is plotted between volume and pressure of the system. The volume is plotted against x-axis. Here along x-axis volume is taken, along y-axis pressure is taken. The pressure volume curve for a fixed temperature is called an isothermal curve. This is for isothermal curve from between the points A and B. The work done by an expanding gas, is equal to the area enclosed between the PV diagram. In a PV diagram, the slope of the curve for adiabatic process is greater than that of the isothermal process. The slope of the adiabatic curve is greater than the slope of isothermal. That is, adiabatic is steeper than the isothermal. Here these two graphs indicates PV diagram or indicator diagram, one for isothermal and another one is adiabatic. That's all. Thank you.